Greetings to you all. This is Mugomba, teacher Dr. Mugomba Ronald. Today we are going to start a series about metabolism. And basically today we are going to go ahead and look at the process of glycolysis. That is glycolysis. That's what we are going to basically be looking at for today. Glycolysis. So glycolysis in simple terms simply means it comes from two words, glyco and then lysis. So glyco means sugar and lysis means splitting. So when we are looking at splitting of sugar molecules, then that means that is what we usually talk about as glycolysis. So glycolysis is one of the steps involved in the process of energy production. So when we're looking at glycolysis, we basically look at the splitting of a sugar molecule. And during the splitting of the sugar molecule, we shall basically be seeing the production of energy as a result. So teacher Dr. Mugomba Ronald, consider to subscribe, like the YouTube channel and share with you. So we shall begin with the process of, so during glycolysis, we are going to basically first look at what happens to the glucose molecule. So it all begins with, so when you look at the process of glycolysis, it begins with glucose. The first process is usually, the first two steps are usually what we usually call activation. First, we need to activate this glucose molecule to prevent it from going out of the cytoplasm. So during activation, we usually see the glucose molecule undergoing activation. The first step of activation is usually addition of a phosphate onto the glucose. So this usually happens from donation of it donates a phosphate group from ATP. So that is why when you look at this reaction here, you can see that ATP comes into the reaction and we get rid of the ADP. We lose ADP. That means that ATP has donated a phosphate, and this glucose now becomes glucose 6-phosphate. Glucose is a 6-carbon sugar. Now, what happens is the phosphate that has been taken up is going to be placed at carbon atom number 6 of the glucose molecule. This all happens in the presence of an enzyme known as hexokinase enzyme. And this reaction is a one-way reaction. It is not bidirectional. That means it cannot be reversed. That's why you can see that it has been represented by a single arrow. Now, after that has happened, the reason as why we usually activate the glucose molecule is we want to prevent it from moving out of the cytoplasm. That is the first reason. And then we want also make it more able to bind with enzymes in the cytoplasm. We don't want it to move out of the cytoplasm, and we want it to be more acceptable to the enzymes which are found in the cytoplasm. So after that has been, we have formed glucose 6-phosphate. The next process is known, the next reaction is known as isomerization. In isomerization, we see a change in the orientation of the carbon atoms in the ring. So we can now see we are moving from glucose 6-phosphate to fructose 6-phosphate. Fructose is an isomer of glucose. So it is another way you can represent glucose. So you just see kind of an isomerism taking place, and this one is catalyzed by glucose, by phosphoglucose isomerase enzyme, where we see a structural change in the way the carbon atoms are arranged in the ring. So that is basically what we talk about here. We are seeing a change in the structural arrangement of the carbon atoms in the ring from glucose 6-phosphate to fructose 6-phosphate. Now, that takes us to, now our next reaction still is, we are still spending more ATP into the reaction. And that other reaction is, we are seeing still phosphorylation of the fructose 6-phosphate. And this happens because we add an ATP molecule into the reaction and we get rid of an ADP molecule. So you bring in ATP and then you take out ADP. In that way, we shall end up with fructose 1,6-bisphosphate. Fructose 1,6-bisphosphate. Now, fructose 1,6-bisphosphate, that means that the first phosphate has bound to the first carbon in the fructose, and then the other one has bound to the second carbon. But we should remember with maximum emphasis that this one is also a 6-carbon molecule. And the enzyme that catalyzes this reaction from fructose 6-phosphate to fructose 1,6-bisphosphate is known as phosphofructokinase enzyme. Kinases are enzymes that catalyze transfer of inorganic phosphates or molecules like inorganic phosphates from one atom to another atom. Now, in this case, we are transferring a phosphate from ATP to fructose 6-phosphate from fructose 1,6-bisphosphate. Now, the next reaction is, now we are going to see, we are going to go ahead and look at another. Now, this is kind of lysis. The next step is what we usually call lysis. So we have been handling activation. In our previous statement reactions, we have been looking at how the molecule is activated. Now, what happens next is lysis. In lysis, we are going to see this fructose 1,6-bisphosphate being broken down into two molecules under the presence of an enzyme known as aldolase enzyme. So these two molecules that are formed include this reaction is reversible. That is why you can see the arrows pointing up and then arrow pointing down. So it is a reversible process. So we usually see glyceraldehyde 3-phosphate and dihydroxyacetone phosphate, dihydroacetone phosphate and glyceraldehyde 3-phosphate. They are interconvertible. That means that you can convert each of them to the other form. We usually convert each of them to the other form. But what usually happens is the fact that this dihydroxyacetone phosphate is usually converted back into glyceraldehyde 3-phosphate under the presence of triose phosphate isomerase enzyme, and we end up having glycolysis continue. It should be noted that these molecules, glyceraldehyde 3-phosphate and dihydroxyacetone phosphate, they are 3-carbon molecules. So now so usually we convert dihydroxyacetone phosphate into glyceraldehyde 3-phosphate. Now it is glyceraldehyde 3-phosphate that continues in the process of glycolysis. So that means that we end up with two molecules of glyceraldehyde 3-phosphate that are going to continue in the reaction. So now when we continue with the glyceraldehyde 3-phosphate, what usually happens thereafter, what happens thereafter is the fact that we see glyceraldehyde 3-phosphate undergoing an oxidation reaction, where we see it getting rid of, we can see it clearly that it is getting rid of protons, and these protons are being used to reduce NAD into reduced NAD. You can see that. So what happens is we see protons being released from glyceraldehyde 3-phosphate to reduced NAD. Now, after that is done, you can see then also another molecule that is added into this reaction is this inorganic phosphate. An inorganic phosphate is added onto glyceraldehyde 3-phosphate. This inorganic molecule could be coming from other molecules, other high energy phosphate molecules in the body, like phosphocreatine. Phosphocreatine could be the source of this inorganic molecule. So when glyceraldehyde 3-phosphate is oxidized in the presence of glyceraldehyde 3-phosphate dehydrogenase, the enzyme is called dehydrogenase simply because it is catalyzing removal of a hydrogen, or it is catalyzing oxidation, removal of protons from glyceraldehyde 3-phosphate. That removal of protons and at the same time addition of an inorganic phosphate, that gives us 1,3-bisphosphoglycerate, 1,3-bisphosphoglycerate, or some books you find it being called 1,3-bisphosphoglyceric acid, 1,3-bisphosphoglycerate. This means that this molecule is a 3-carbon molecule, and at the same time it has each first phosphate on the first carbon atom, and then the second phosphate on the third carbon atom. Now, the next reaction is we are going to go ahead and see how we can produce ATP. Now, in this context here, we are seeing a conversion. Sorry, double arrows. When you look at this, what usually happens is we see release of an inorganic phosphate from 1,3-bisphosphoglycerate, and that inorganic phosphate is transferred to ADP, and then when we transfer that inorganic phosphate to ADP, we end up forming ATP. But you should remember that we had 2 molecules of glyceraldehyde 3-phosphate. That means that even here we have 2 reduced NAD, even here we have 2 ATP molecules formed. The enzyme that is involved in this reaction is known as phosphoglycerate kinase. Phosphoglycerate kinase is the one that catalyzes the formation of ATP from ADP and an inorganic phosphate, which has been picked from 1,3-bisphosphoglycerate. So now the next thing we can look at is the fact that what usually happens now, we're having only 1 phosphate remaining at carbon atom number 3. It is the one that is remaining here. What usually happens now, we see some kind of mutation. We can see some kind of mutarotation in the molecule. And then we see some shifting of the phosphate molecule. The phosphate atom is being, or the phosphate functional group is being shifted from carbon atom number 3 to carbon atom number 2. And we end up with 2 phosphoglycerate. This means that the phosphate was previously at carbon atom number 3, but now it has gone to carbon atom number 2. This is catalyzed by an enzyme known as phosphoglycerate mutase enzyme. After that is done, but bear in mind that we are having 2 molecules at every step. At every step we are moving, we are having 2 molecules. Why? Because we saw dihydroxyacetone phosphate being converted to glycerate 3-phosphate, glyceraldehyde 3-phosphate under the influence of triose-phosphate isomerase enzyme. So we ended up with 2 glyceraldehyde 3-phosphate molecules. So at every step, we usually talk about 2 molecules. Now, these 2 phosphoglycerate usually in the presence of enolase enzyme undergoes a dehydration reaction where we see release of water. After that, then that enables us to form a molecule known as phosphoenolpyruvate or PEP. This molecule here known as phosphoenolpyruvate or PEP, it is usually a 3-carbon molecule, and then this phosphoenolpyruvate loses its phosphate to ADP to form ATP. It loses its phosphate to ATP to form ADP to form ATP, and in the due course we shall end up forming pyruvate. So that is in the presence of an enzyme known as pyruvate kinase enzyme. Remember, kinases are very important when it comes to transfer of functional groups. Basically, in this context, we are seeing a transfer of a phosphate from phosphoenolpyruvate to ADP to form ATP, and in the due course we shall form pyruvate. Now, so the first thing we need to go ahead and see the different reactions that happened in the glycolysis. This process of glycolysis involves splitting of a sugar molecule known as glucose into 2 molecules, and that splitting emits some energy and at the same time emits some protons, which are immediately taken up by electron acceptors. So let's go ahead and balance the sheets and look at what happens usually and look at the mathematics behind. So when you look at the balance sheet, for the phosphate bonds of ATP, usually we have 2 ATP molecules which were expended. We saw the first ATP molecule which was used when we were converting fructose 6-phosphate to fructose 1,6-bisphosphate. That was the first one. And so it was the second one. Then the first one was the conversion of glucose into glucose 6-phosphate. It also used ATP. So those 2 ATP molecules were used. But we have produced 4 ATP molecules. one from from the conversion of one was produced when we are converting 1,3-bisphosphoglycerate to 3-phosphoglycerate. That produced 2 ATP molecules. Then the other pair was produced when we are converting phosphoenolpyruvate to pyruvate. So that we have 2 pairs, 4 ATP molecules we are produced. Now, we have a net of 2 ATP molecules. Why? Because we subtract the 2 that we are used, so we end up with the 2. When you look at reduced NAD that we formed only 2 reduced NAD, and it is going to go ahead and be taken to the electron transport chain, where it will be used to form 2.5 ATP molecules, and in some books you'll find them being said that it produces 3 ATP molecules by rounding off. I remain teacher Dr. Mgombo Ronald. Consider to subscribe. Today we have been looking at the process of glycolysis. Consider to share if you have benefited. Consider to like and place in your comment. Thank you so much for staying on till the end. We have been looking at glycolysis.